Hi everyone, and thank you for joining my talk. Are we forever doomed by software supply chain risks? If you joined this talk, then it means you care about software and you care about software security, which is great. Most of all, you probably are curious like I am, how does open source software supply chain risks impact all of us, you, me, everyone here? So I wanted to begin this with interesting stories such as, let's take a moment to reflect on this picture, what you're seeing on your screen right now, and what comes to your mind. Is it the futuristic outlook of the world, like the robots, are they uprising and becoming a key part of our lives? Perhaps it's other things like how much does the robot actually learns and uploads all of that to the cloud? Where is it stored? Is it stored safely? What happens when someone can do something malicious with that data? Most of all, what happens if someone hacks in and interacts with my child? This is my kid, if so to say, and what happens when that interaction takes place, when someone is able to compromise that? So yeah, with that we are getting started. These are some of the things that are keeping me up at night. And today, I would like to share with you some real-world stories of how developers play a fundamental role in recent and growing security incidents. And also, why should you care about security, software security, and software supply chain risks? And also leave you off to think about who do you actually trust? So, in case you had a doubt, we're seeing more and more open source software being developed. Year after year, right? Open source software repositories are growing with more and more open source software, and that is more software footprint. The thing is, the application that we build are ever growing in their dependency of open source software. Not just the fact that we're using open source software, but applications themselves are using more and more of that as well. So more of us, basically software engineers, are now accustomed to the way of how people work in open source, like opening issues and becoming maintainers of open source. More and more of us are maintainers of open source software. And that growth of open source software doesn't come without any risks, right? This is why we're all here, because we care about it. We are continuously witnessing the growth of open source software security vulnerabilities in these ecosystems like NPM and Java and others. And this could be anything from CVE-based vulnerability reports that, when you install a software, you get that installation that said, there are 1,000 vulnerabilities there. What happens when that takes place? Also, the incidents themselves of malicious packages and different targeted attacks on developers, because us as developers, we rely on open source software packages, and so we are targeted as well. And I will get to that right now. Let's rewind back, first of all, in time to get an early glimpse of how one developer perceived the risks of open source software. So in 1984, the Turing Award-winning Ken Thompson wrote a short essay titled Reflections on Trusting Trust, in which he describes how he added a backdoor to the Unix login C program, and then he continued and added a backdoor to the C compiler, and then he added a backdoor further on with his chains of attacks into the compiler that compiles the C program, that compiles the compiler. Right, so in his paper here, about reflections on trusting trust, he actually explains how software can be taught to learn specific traits and pass them on. So realistically, it is very, very hard to find the traces of things like Trojan horses and backdoors unless you have actually written everything from scratch. And I mean everything, such as the compiler, the linker, the CPU, the display that you're watching something, the keyboard, everything. It is very hard to trust an ecosystem. So as we learned by Thompson's Trojan horse story, this is dating back to 1984, developers have been targeted as a vehicle to distribute malicious backdoors and other sorts of malware for a very long time now. Let's explore some of these incidents. I'm sure you've probably heard of some of them. In 2018, the JavaScript ecosystem witnessed its first high-impact spearheaded targeted attack on maintainers and developers alike, where they are working in open source in the ecosystems themselves and actually have been the attack target, the attack vehicle as well, to actually distribute malicious JavaScript code to all of us using those software. And so the attack itself targeted also developers using open source, and specifically a Bitcoin wallet application, and this was the well-known event stream incident. Event stream existed on the NPM registry since 2011, for a very long time now, as you could see. It practically didn't receive any new releases in the last 2 years, but gained millions of downloads per week. Out of the blue, someone chimes in and says, I want to help. They get into the project, they help, they open a pull request as you normally do in open source software. One of those pull requests later has actually introduced a dependency. At that point in time, this was a trusted individual, so they received a different kind of access to the repository and publishing new packages and new versions of that package and so on. And later on, when they added that dependency, now that dependency exists in a different state, and they could just add that backdoor to that new version that they released, and now new versions of EventStream that use that dependency pull the new version in, and they get that dependency with the backdoor that now the original maintainer of EventStream did not know about. They did not know that this is happening, and they can't control it, because this is how software package managers work in specific ecosystems like NPM, like others. So this actually resulted in 2 versions of the Copay Bitcoin wallet application, including the malware, 3 months, for 3 months until we found this. This is the EventStream one. Now, an academic research paper published in 2019 investigated these properties of language-based software ecosystems, and it found that more than a half, 61% of open source packages on NPM could be considered abandoned because they did not receive any release in the last 12 months. Exactly what happened with the EventStream story. And as if we didn't learn anything from this incident, 1 year later, a similar action comes into life. Electronative Notify, and a similar incident happening. What happening in short, right? This one point in time, this Electronative Notify package, which is not malicious, but it's added as a dependency to a different project, this EasyDex GUI thing. Later on, that the developer that owns Electronative Notify releases a new version that now includes a malware, a backdoor to it. What happens? The Electronative Notify project is now embedded into a different app, this EasyDex things, which now pulls a new version of Electronative Notify with the malicious version and releases new versions. Again, sounds similar? Exactly what happened before. How much thought are we actually giving to the security of our own development infrastructure? For example, resources like cloud instances and your continuous integration tooling. In January 2021, a security researcher broke into Microsoft Visual Studio Code GitHub repository. Essentially, this is providing him any capabilities like read and write access to modify the code of the very well beloved IDE VS Code that many developers love. But due to command injection that this researcher had been able to exploit, it was able to give him an attack vector to basically create code injection. Now, by opening a pull request, all he had to do, open a new code pull request, this researcher can now execute code into VS Code's own CI ecosystems without being authenticated or authorized. All of this really just provides him the ability to create, submit, or if you would like to say spawn, remote reverse shells on the CI servers running code, and from that being able to basically push and write access to the repository itself. Now, fortunately for us, so all of us here in this ecosystem, this researcher responsibly reported the flaw to Microsoft before hopefully anyone else could have gained access to it. But you have to ask, right, how much do we know about the current state of open source security? What does it actually entail? So in an effort to explore the security awareness of Python and JavaScript open source communities, a group of researchers investigated how maintainers work in the open source community and how do they release fixes relating to security vulnerabilities. One of the research questions was, how quickly do maintainers mitigate a newly published security vulnerability? Once it's published, once there's a CVE out. The research found that it takes almost 100 days on average for both JavaScript and Python maintainers to start mitigating a vulnerability. You have to ask yourself if this is fast enough. And this is a bit different because between the different communities, because for Python, it has been remediated much sooner versus JavaScript, which took its time from 2018 until now to basically be a bit more mature and aware about these security risks. As a case study exactly of this, we can refer to Marked. It's a library, Marked's own security vulnerabilities from several years back. Now, what happened is this Marked is a markdown library. It's a parser for JavaScript and Node.js, and it's very popular, getting millions of downloads a week. One day, a security researcher just pops up, open a code pull request to fix a vulnerability. So this is, all you have to do is merge it, basically, as you can see here. But as it is with open source software, maintainers are really trying to do their best, but they're not contracted or obligated legally or something to support you. So me as a maintainer, you, everyone else, we're really trying to do our best and in time of what we can do. But this vulnerability stayed out there for a year, knowingly exact what's happening with this, and this security vulnerability itself being public for more than a year. When we're all so much very dependent on open source software, we can't ignore the question of, where do we put our trust? What are the mitigations and controls that we have to cope with the risks involved? In 2017, a security researcher working with the Node.js Foundation conducted a research which he wanted to explore and assess, right, the state of weak NPM credentials on the NPM registry. His work really revealed devastating truths about developers and their lack of security hygiene. What I mean by that is, this security researcher was able to gain publish access to 14% of NPM ecosystem modules. This is a lot. Some of these modules were downloaded millions of times, tens of millions of times a week, and they are still an essential key part of this, thriving JavaScript ecosystem, which I am also a part of. So this is, very concerning for me as well. The thing is, the problem was rooted with insecure passwords chosen by well-known maintainer accounts, such as literally the word password for one of the accounts running millions of downloads for one of their packages. So if it can happen to them, it can happen to other packages as well. If our code packages can reach millions of developers, shouldn't we have more protections in place as citizens of open source communities? Shouldn't we do better for our account hygiene? So you would imagine so, but in NPM, the largest registry of open source software, even though two-factor authentication was enabled since 2017, only 7.1% of NPM package maintainers have enabled 2FA. You'd think that we have done better so far, but a year later, by 2020, another interesting insight that we get into what has been happening is that it has only grown by 2%. Only 9% of developer accounts on NPM by 2020 have enabled 2FA. We should do better. As cybersecurity expert Bruce Schneier says, and had said and written in his book Secrets and Lies, humans often represent the weakest link in the chain. Think about it as you go and think about this term. Given enough eyeballs, all bags are shallow. As a term coined by as Linus's law back by Eric Raymond in his work The Cathedral and the Bazaar at 1999. He explored the differences of how software development takes, different shapes between open source and enterprises. And one of the things was that, if everyone are looking at it, we'll find the problems. There are a lot of people looking at this code. Really, are we going to find it? Because in January 2021, it was discovered that sudo, a common utility installed on many Linux distributions, had a security vulnerability. Specifically, it allowed any unprivileged users to gain root access simply by the default sudo configuration. Now, this was so daunting as a vulnerability because it was hiding in plain sight. This is from the disclosure itself. For a whole 10 whole years, this was just showing up there. Now, we can't deny being a part of these open source ecosystems as consumers, contributors, or maybe even as maintainers for some of us. We all play some part in a world where 90% of our application code is open source software components. We reached a point where we take open source for granted, right? Open source registries are open in their nature. Anyone can go in and publish their new packages, even malicious ones. You'll be surprised. Maybe it doesn't get caught. We have been accustomed to this, opening and issuing a project source code or asking for help, asking for a feature, asking someone to get our bug fixed, hopefully. But we import those open source into our projects, and do we understand what's going on at that point in time? Because open source registries are open in their nature, but they're not going to be there all the time. What happens when maintainers remove their packages and dependencies? And this is a story that exactly happened, and for a package that was very pivotal in the ecosystems, but caused a widespread breakage of continuous integration systems all around. So at the very least, it taught us that enterprises and organizations that were prone to this attack were not understanding how to deal with open source software, and registries themselves did not know either. They were missing how even this could be possible, and would it be possible? What kind of malicious activities and assets can we track back to open source software? Time after time, we're finding more malicious packages hitting the NPM ecosystem, typo spotting mistakes and others. But they're not only a sole problem of the npm, the JavaScript ecosystem, because PyPI had also seen thousands of packages just brute forcingly published in bulk to basically add malicious packages. To further show us how attackers can actually harness open source to their advantage, Alex Burchan published his research in February 2021 about how he exploited design flaws in package managers and human errors and registries basically to infiltrate into corporations like Apple, Microsoft, and others. And so all of this is happening in open source. And I would like to leave you off with some questions. Are we going to have less or more software in the future? Are we going to use more open source software in the future? Who do you trust and what can you do about it? Thank you for coming to my talk. My name is Liran Tal. I'm a developer advocate at Snyk, where we build a security platform to help developers build securely with open source software. Thank you all for joining my talk. Have a nice conference.